Okay, so we're going to start example number 2, which is to graph a linear inequality of the form ax plus by is greater than c. Notice our inequality just reads greater than, not equal to, so that's going to change how our graph looks. You might want to try this on your own and pause your video and come back to it once you have completed it and see how I solve it. Okay, so we're going to graph 10x minus 5y is greater than 0. This is in general form. And I'm going to use method number 1, which is to graph using y equals mx plus b. And I'm going to combine steps 1 and 2. I can get the same information regardless of whether I change my inequality to an equality or not. So I'm going to get 10x minus 5y is greater than 0. I want to isolate for y. And so I get negative 5y is greater than negative 10. And I notice that I'm going to be dividing both sides of my inequality by a negative number, and in this case, negative 5. So if you go to the right, and just remember something that you learned from grade 9, to reverse the inequality sign when dividing or multiplying both sides of an inequality by a negative. And that's what we're doing. So our greater than sign is now going to become less than, and so what we are left with is that y is less than, oh, this should be x, shouldn't it? 2x. Okay, so this is in the form of y equals mx plus 2b. Notice we don't have a value for b, so I'm just going to put a 0 in here. I don't expect you to do that, but just for the purpose of our lesson, I'm going to do that. So the information that I get is that my slope is 2, or if you like, 2 over 1, and my y-intercept is at 0. So we can graph our line right now, and because we don't have an equal to on this inequality sign here, we're going to graph it as a dotted line. Okay, so let's start with our y-intercept, which is at 0. We have a slope of 2 over 1, which means we're going to go up 2 and to the right 2, 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 and then down 2 and to the left, down 2 and to the left 1, down 2 and to the left 1, and we graph with a dotted line. Now, remember when you label this line, though, we don't use the inequality, we use the equality, so y equals 2x. Now we want to discuss what our less than sign means. Okay, so notice our y is on the left-hand side of our inequality, so our less than sign means to graph below the line. And use a dotted line. Okay, now we are also asked to verify. Oh, right. Okay, so we should really graph that, shouldn't we? All right, so it means below the line. So that means I want to graph everything below our line. Now we want to test to see if that is for sure, okay, that's really what our region is. And so we want to pick a test point in our shaded region. Now I'm going to pick one, like I say from before, that's kind of easy to use, right? So I probably want to pick one that has 0 in it. So I'm going to pick this point right here. It's in our shaded region, and it's at 0 and negative 2. This is my test point. Okay, so I'm going to plug that into my original inequality. So 10x minus 5y is greater than 0. And in place of x, I'm going to put 0. And in place of y, I'm going to put negative 2. And I get 0, and negative 5 times negative 2 is 10. So I get 0 plus 10, which is just 10. Is 10 greater than 0? Yes, it is. That is true. So our shaded region is correct. Okay, so that ends our discussion on example number 2.